Jose is purchasing a new car for $27,500. If the value of the car decreases at a rate of 11% per year, approximately how many years will it take for the value of the car to reach $12,000? So we got a real world problem here, and I want you to just kind of think about it, practically speaking, that if I put the cost on the y-axis and put time on the x-axis, let's just think about the value of a car. I mean, it says the original value, but would the value of the car just drop like this and go all the way to 0? No, so it's not quadratic. I'm trying to walk through the shapes here. What's actually going to happen is the value of the car decreases over time, but it never actually gets to 0. So it'll kind of decrease over time, but it'll curve this way. So it's not a line, like it won't just go like this and then become a negative cost. It'll actually just curve like this, and it'll be less and less, but it'll always have some type of value. It just might get very little. This is an exponential graph because it's approaching the x-axis. Remember, exponentials look like an airplane landing, and so this is the idea of the graph. Because of that, we're looking for an exponential equation. We have formulas on the formula chart for exponentials. Here they are, exponential functions. So if it's something that's happening a certain amount of times per year, we use compound interest. So the n would refer to how many times per year. Like if it was happening only once a month, that would be 12 times a year, you'd put that for then. But this, a car value doesn't change only once a month, it's always changing. So you actually use this one, A equals what we call PERT, P times E to the power of R times T. Principal times the function E to the power of the rate times the time. That's the formula here we're going to use. This is going to be our y value. That's going to represent our y. We want that, that's the final amount, we want that to equal $12,000. So this is going to be $12,000. The P stands for the starting amount, which is $27.50. Let me put that there. Let me put that there. So this would be $27,500. And then the function E, that's a value, or it's like 2.72 or so. And that's going to have a rate and a time. We have the rate, it's 11%, and it says it's decreasing at 11%. That actually means it's a negative 11%. That's a rate of negative 11% because it's going down. Times time. And we said that time represents x, so I'm actually going to replace this with the x here. So there's my formula. Here, I plugged in all the pieces that I know, which are 3 of them, and I substituted t for x. And you could graph this, and I'm going to graph this as an equation, and this as an equation, see where they intersect. And this should give us their time. So I'm going to come back over here. Go to graph. And so the first equation was 12,000. That was the left side of the equation. The right side was 27,500 times e to the power of negative 11% times x. Now, right now, I can't see the graph. I need to change this up here. So what I'm going to do is change this from 6.67 to 27. The value is 27,500. I'm going to go above it. I'll just say 30,000. Now that I can see the value I'm looking for, they intersect. So this will give me the time. If I analyze graph, choose intersection, I go to the left and the right. It happens at 7.54 years. So that would be our option here. It doesn't tell us what to round to, so I'm just going to put 7.54. And then I'll show you quickly how to do the algebra here if you wanted to do so. If I wanted to solve using algebra, the way you do solving algebra is you try to get the x by itself. So the first thing you would do is you would divide by 27,000. So take the 12,000, divide by 27,500. So I divide those two numbers. And that will equal e to the negative 11% times x, which is the same thing as negative 0.11x. Now I have this. Now we could simplify this, but I don't want to be working with crazy decimals the whole way, so I'm going to leave it just for a second. The way to solve for an exponential is to flip it to a logarithm. So remember, when you change it, we right now have a base, a power, and a number. The way you flip it is the power, where the x is, and the y, they switch places because the logarithm is the inverse. My base is e, so instead of saying log of base e, I'm actually going to say the natural log. That means my base is e, and I switch these two values. So the natural log of 12,000 divided by 27,500 will equal this value, negative 0.11x. And finally, the last step would be to divide by negative 0.11. And so I'll type this in the calculator, and this should give us our x value of 7.54. And it might give us a more precise value. So I'll come over here, calculator, the natural log of 12,000 divided by 27,500, and all of this will be divided by negative 0.11. And you'll see that's where this value is, a more precise answer. That's how many years it would take.